So on this, okay, so on this major street, right, we've got the center right here. That's literally in the center of the ellipse, okay? We also have what we call the vertices. The vertices are the endpoints of the major axis. And the foci are also on the major axis. So on that major axis, you hit the vertices, the foci, and the center, okay? And the vertices and the foci are probably of the points the most important, and then the vertices, and then you have a secondary street here called the minor axis. The minor axis is this one, and that's shorter than the major axis. On that minor axis, you have what we call covertices. So if you look at the ellipse, you know it's longer on one side than it is on the other. The longer side has vertices, the shorter one has covertices. But just remember, the most important thing you need to remember is that the vertices, the foci are both on the same line, okay? All right, now distances. Let's talk about distances. Here's the center, and everything is defined in reference to the center, okay? From the center to a vertex, that distance, so if you measure that distance, it's A. Okay, so that's the letter A. If you measure the distance from the center to the vertex, okay? If you measure the distance from the center to the covertex, that's B. And if you measure the distance from the center to the focus, that's C. Okay? So A goes from center to vertex, B goes from center to covertex, C goes from center to focus. Now, looking at the ellipse, whether it's this ellipse here or this ellipse up there, okay? If you look at the distances, A, B, or C, which one of those is the largest distance? A is the largest distance, right? Because it goes the further out from the center. So A is the largest distance. Now, A, B, and C are luckily related to each other in a handy-dandy formula, right? A, B, and C. What's the Pythagorean theorem? Right, A squared plus B squared equals C squared. This is not that, okay? And I purposely say it like this every single time because I want you to remember that you're not using A squared plus B squared equals C squared. It's a whole other combination. B squared plus C squared is equal to A squared. So what does that mean? Are we going to get confused each time we have to use that? No, because why are we not going to get confused? Because you're going to know it because it's different, and how do we remember it? What's the largest distance between A, B, and C? A is the largest distance. It means B and C, which are smaller, add up to give you the largest distance A. Make sense? All right. So this is how the three of them are related. All right, let's do some actual ellipse work. Okay. The equation for an ellipse is this. Okay, oh my goodness, how confusing. How are we going to remember this? It's amazing, but you will. Trust yourself, and you will. Okay, so here are some characteristics for the equation of an ellipse. You see the x variable and the y variable? They are both squared, okay? There is a plus in the middle. It equals 1. And these numbers here are not the same. A and B are not the same. Okay? That's how you know that it's an equation of an ellipse. So if I was walking down the street and if I saw an equation on a billboard, okay, I go, oh look, the x and the y are squared. Oh my god, there's a plus in the middle. Oh, it equals 1. And oh my god, the denominators are not the same. That is so an ellipse. Okay? That's an ellipse. That's how you tell. Because if any of those things that I mentioned were different, then it would be another shape. A hyperbola, a circle, a parabola, okay? All right, now, this is a horizontal ellipse, okay? This is a vertical ellipse. What is the difference in just the equations? What's the one difference? The A and the B. Okay, so look, between the A and the B, which one is the larger distance? A. Whichever variable A is with, that's the orientation of the ellipse. So if A is with the X, the ellipse is horizontal. If A is with the Y, the ellipse is vertical. Okay? So here, the larger distance is along the X, horizontal. Here, the larger distance is along the Y, vertical. Okay? I'll take questions in a sec. Now, this is a horizontal ellipse. That means if I'm at the center, by the way, is always H and K. Okay? Now, if I'm at the center and I have to go to the focus, do I go horizontally or vertically to go to the focus? I go horizontally. That means if I go horizontally, does my Y value change at all? No. Which value does change? X value. Now look, the distance here is C, right? So suppose that's like 3. That means if I'm at the center, I have to go 3 to the right, 3 to the left. That means whatever my H value was, I have to add that to my C. Okay? And K stays the same. Huh? Yeah. Yeah. So look, if everything is horizontal, the X value changes and you add C to it. Now what about the vertex? To go to the vertex, if it's horizontal, do you change the X or the Y? The Y stays the same to go to the focus. The X changes, right? So you add A to your H. Okay? If I'm at the center and I have to go to the vertex, do I move horizontally or vertically? Horizontally. Okay? All right, look. If I'm here, how do I go to the co-vertex? You go up. That means your Y value changes, right? So you add that to your Y value. All right, take a look at this one. Just by looking at this equation, is this a horizontal or a vertical ellipse? It's a horizontal ellipse because the 9, which is the bigger value, is with the X. This is a horizontal ellipse. Okay? Now, I need to graph this, but first I need to figure out all of the different points. Okay, what is the center of this ellipse? It's -2. You take the opposite sign. -2, so H comes from here, -2, and K comes from here, +1. That's the center. So at -2 and +1, I have a center. Okay? Now, that number, the 9, is my A squared. A squared is 9. So how much is A? 3. B squared is how much? B squared is 4, so how much is B? 2. Now, if I have A and B, can I find C? Yes. What's the formula? Right, B squared plus C squared equals A squared. So let's find C then. B squared plus C squared is equal to A squared. That means 4 plus C squared is equal to 9. C squared is equal to 5. So how much is C? Root 5. Okay? Remember, C is a distance, so it's positive root 5, not plus or minus. Okay, now, what I need to find now are the foci. Okay? If this is my center and this is a horizontal ellipse, am I going to go horizontally or vertically for the focus? Horizontally. That means everything is going to be on this line. Okay? What's the Y value going to be for all of those points? 1. The Y value will not change, but the X value will change. So what I do is this. The center is at -2 and 1, right? I say -2 plus root 5, comma 1. Negative 2 minus root 5, comma 1. Okay? All right. So with our calculators, how much is negative 2 plus root 5? It's 0.24 for this one. I'll get you in a second. And it's negative 4.24 for this one. From the center, you have two foci. One is to the right and one is to the left. So you have to add root 5 to go to one focus and subtract root 5 to go to the other focus. Oh, about this one? Oh, they should both be a positive one, actually. Not negative one, positive one. All right, so let's plot the foci here. So one is at 0.24, comma 1, and the other one is negative 4.24, comma 1. 0.24, comma 1, negative 4.24, comma 1. Huh? What is it showing? This is a projector thing. So, okay. So, those are my foci. Now, what about the vertices? I have to do the same thing to the vertices. So, that's another thing to remember. You find vertex and focus the same exact way. So, whatever you did to find focus, you do the same thing to find vertex. All right, so for the vertices, all right, it's going to be, you're going to add A to H again. So it's going to be negative 2 plus 3, comma 1, negative 2 minus 3, comma 1. That's going to give me 1, comma 1, and negative 5 and 1. Okay? So 1 and 1, negative 5 and 1, those are my vertices. And we do label them like this. With a little f. Okay, now for the covertex. For the covertex, remember, whatever you did for focus and vertex, for the covertex, you're going to do the opposite. So this time, you're going to add your B to the Y. All right, so for the covertex, it's going to be negative 2, comma, 1 plus 2, negative 2, 1 minus 2. So this is negative 2, comma 3, negative 2, comma minus 1. Negative 2, comma 3, that's my covertex. Negative 2 minus 1, that's my covertex. Okay, and now I'm ready to graph my ellipse. It looks just like this. Ooh. Okay, that's how it looks. So that's your ellipse. All right. We're going to do one more, and this one's a little bit more fun. Do you remember completing the square? Of course you do, because we did it in the last lesson. We're going to do it again, okay? All right, so we're going to have to complete the square to put the equation in standard form. All right, so here are the x's that we're going to combine. Here are the y's that we're going to combine. This number is going to move to the other side. All right? Now, here, you factor out a 4 because you can never have a number in front of the x squared. So 4 times x squared plus 6x. And you know, to complete the square, we do plus a number. Same thing. Plus y squared minus 10y plus a number equals, when the negative 3 moves over, it becomes positive 3, plus, we added two numbers, right? 10y. We added two numbers, remember? Because in the first one, we took out a 4. Here, it has to be 4 times a number in order to keep the equation balanced. Okay? So what goes in the first blank? 9, and 9 here. What goes in the second blank? 25 and 25 here. Okay? All right, so here we have 4 times x plus 3 squared plus y minus 5 squared is equal to what? 3 plus 36 plus 25, how much is that? 64. That doesn't even look like an ellipse. Because what's the equation of an ellipse supposed to equal to? 1. What do you do to the 64 to make it a 1? You divide by what? 64. Divide by 64, divide by 64, divide by 64, and now look at what happens. It's almost magical. It's x plus 3 squared over, what happens when you reduce these two numbers? 16 plus y minus 5 squared over 64 is equal to 1, and that's your equation of an ellipse. Okay? Awesome. So now, what's the center of that ellipse?
Negative 3, 5.
Negative 3, comma 5. So now, yeah, it could be anything. No. Yes. Okay, so how much is A? A squared is 16, A is 4, how much is B? 8. And C, B squared plus C squared is equal to A squared? Oh, I'm sorry. Thank you. Which one of those is A and which one of those is B?
64 is A.
Right, this is A and this is B. Like 8,000 brownie points for you, Henry. Okay? Right, so then what does that mean? Is this a horizontal or a vertical one? Vertical. So at negative 3, comma 5, which is there, okay, I'm actually going to renumber these. Huh? I'm just renumbering them. I'm just making this 4, 8, 12. Yeah. Okay, so, and I'll make this negative 4 and negative 8. Okay, so at negative 3, comma 5, that's right there. That's the center. Okay, now, how much is C? It's 16 plus C squared is equal to 64. So C squared is equal to what? 48. So C is root 48. All right? Now, if this is a vertical ellipse, right, that means the vertex and the focus are going to get added to the y. Okay? So to find focus, it's going to be negative 3, comma 5 plus root 48. Negative 3, comma 5 minus root 48. So how much are those? 11.9. And I'm doing this one. You guys are going to do the next one. Negative 1.9. So at negative 3 and 11.9, we have a focus. And at negative 1.9, we have another focus. Now, the vertices, same exact situation. You add them to the y. So it's negative 3, comma 5 plus 4, negative 3, 5 minus 5 plus 8, and 5 minus 8. Okay, so what do we get there? Negative 3, comma what? 13 and negative 3. 13 and negative 3. Those are my vertices. The co-vertices are going to be, the B is going to be added to what? H or K? Here we added to the Y, so here we're going to add to the X. So the compact way of writing it is we can say negative 3, instead of saying negative 3 plus 4, negative 3 minus 4, negative 3 plus or minus 4, comma, 5. So this is negative 3 plus 4, which is how much? 1 comma 5 and negative 7 comma 5. Okay? So 1 comma 5 and negative 7 comma 5. Okay? So finally my ellipse is horizontal, is vertical, and it looks like this. Yeah. All right, why don't we go backwards now? Let's actually write equations for these. Okay, so we're going to write an equation. What we have here is the major axis. It's from this to this. Okay, so what I do is I just sketch it roughly to myself, right? The major axis is from 5, negative 2, so here, to negative 1, negative 2. If that's the major axis, is this a horizontal or a vertical one? It's a horizontal one. Okay, now, if you go back to the major axis to how I defined it before, okay, if A is the distance from here to here, what's the length of the entire major axis? 2A. 2A, right? If this is A and this is A, the entire major axis is 2A, okay? Now, if you go back and rely on your, counting skills pretty much, if you're going, the Y values are the same. If you're going from x equals 5 to x equals negative 1, if you're going from x equals 5 to x equals negative 1, how much is that? How many spaces? 6, right? So 2A is equal to 6. Okay? That means A is equal to 3. Now, because from 5 to minus 1, it's 6 spaces. Now, the minor axis is from 2, 0 to 2, negative 4. So what's changing there? The 0 and the negative 4. Just 2A. Because from 5 to negative 1, if you count from 5 to negative 1, how many spaces is that? 6. And it's distance, it can't be negative. So 2A equals 6. And here the minor axis, right, goes from 0 to negative 4. How many spaces is that? 4. Minor axis gives you B, right? So that's 2B is equal to 4. So B is equal to 2. Now, what's the center? The center is exactly in the middle of any of the pairs of points. Okay? So the center, that's the midpoint of any of the pairs. All right? Let's find the midpoint of these two. How do you find midpoint? You add and divide by 2. So 5 minus 1 divided by 2, negative 2 minus 2 divided by 2. So the center is 2, negative 2. Okay? That's my H and that's my K. Now, this is a horizontal ellipse, right? So what does the equation of a horizontal ellipse look like? X minus H squared over A squared or B squared? A squared plus y minus k squared over b squared is equal to 1. So now x minus h, which is 2 squared, over a squared is 9, plus y minus negative 2 is y plus 2 squared, over 4 is equal to 1. And there you have it.